Fast fighter jets and the weapons they carry are the cutting edge of all combat-focused air forces since the end of the Second World War. The primary source of aerial pacing threats for the whole world and the US's defense leader was the Soviet Union and laterally Russia, but now China comes for this role, developing an advanced indigenous combat aircraft sensor and weapons industry that is outstripping Russia's. Few people know that China has owed a tremendous debt to the Russian bear. Does it mean that the apprentice may have surpassed the master? Coming back a while right away in 1950, the Soviet Union provided Beijing with capable MiG-15 jet fighters and entire squadrons of Russian pilots that eventually compelled the U.S. Air Force to curtail daylight strategic bombing raids along the Yalu River during the Korean War. China subsequently began production of domestic clones of Soviet J-5 as MiG-17, J-6 as MiG-19 and J-7 as MiG-21 fighters. Then after the Soviet collapse in 1991, Russia granted China fourth-generation Su-27 and Su-30 flanker jets, a powerful twin-engine fighter known for its super-maneuverable flight characteristics. The Shenyang Aviation Corporation developed three separate clones of the flanker: the J-11 carrier-based J-15 Flying Shark and the strike-oriented J-16. To be short, China still imports turbofan engines from Russia as it struggles to perfect domestic alternatives such as the WS-10B and eventually the powerful WS-15. However, the latest Chinese fighters increasingly incorporate weapons and avionics that are more capable than their Russian counterparts. We can put it down to three main factors. First, Beijing's annual military spending exceeds Moscow's 2 or 3 times over, as Russians spend $70 billion on defense in 2020. China, $190 billion. Second, China exceeds any country's expertise in the civilian electronics industry, which helps manufacture advanced avionics and Western-style sensors. And finally, China is the best in copying technologies from across the globe through mainly hacking. That isn't to say that the Chinese military holds all the advantages. Most notably, Russian military aviation has far more combat experience, with most of its fighter and bomber crews rotated into combat tours in the Syrian civil war. The Russian aerospace forces also still operate some specialized aircraft types without real Chinese equivalents, such as the MiG-31 Interceptor, Tu-160 and Tu-22M supersonic bombers, and the Su-25 ground attack jet. Russia has also had far more success exporting fourth-generation fighters than China has. Nevertheless, military experts predict that China will take superiority, pulling ahead of Russian counterparts, especially applying the following technologies: composite materials. China nonetheless has taken the lead in incorporating composites in J-11B, J-11D and J-16 fighters, all derived from Russian flanker jets. One of the key weight-saving tricks in modern aircraft design is replacing metal components with lightweight composite materials. Those weight reductions translate into significant improvements in agility and range. The end result is Chinese jets incorporating additional systems compared to the Russian original, yet still achieve a superior thrust-weight ratio. The Xi'an Aircraft Corporation further advanced composite technology by 3D printing composite components and implementing new computer-assisted design techniques for its Y-20 chubby girl transport planes, techniques sure to make their way into future combat aircraft. Advanced radars, the ability to spot an enemy while remaining undetected, is the major advantage for air-to-air combat. That's why a superior radar and greater discretion can wind up being a deadlier advantage than, say, a higher maximum speed. The latest Russian Su-35's jets feature extremely powerful passive electronically scanned array PESA radars claimed capable of detecting an F-16-like aircraft up to 250 miles away, but the Airbus is also extremely conspicuous when active, meaning leveraging its capabilities can leave the operator even more vulnerable to being detected. First, the current gold standard in sensor technology is the active electronically scanned array ASA radar. First introduced in the US, it has a greater range, higher resolution and better capability to maintain multiple tracks than its predecessors. Russia claims to have finally fielded ASA radars for the Su-57 stealth fighter and MiG-35 but hasn't done it yet, and the timing remains unclear. Meanwhile, China incorporates AUSUS broadly into J-11BD, J-15 and J-16 twin-engine fighters, J-10 single-engine fighters and J-20 stealth fighters. Stealth aircraft technology: China's Chengdu J-20 Mighty Dragon, though likely less agile and all-around stealthy than the US F-22, is generally considered the first credible operational fifth-generation stealth fighter, designed outside of the United States. By contrast, while Russia's Su-57 Felon stealth jet appears impressively agile, it's less technically mature. For example, the first production model Su-57 crashed just a few days before it was officially set to enter Russian military service due to a flaw in the flight control system. Although the Su-57 still has some good qualities and is harder to detect than prior Russian warplanes, Su-57s could be a direct competitor with the US F-22 or Chinese J-20. It's considered a very low observable air superiority machine. Beijing simply has spent far more money to develop, refine and procure the J-20 over the years. Photos reveal the J-20 has gone through numerous iterations with improved engines and stealth technology. The Shenyang Aircraft Corporation has also independently developed another stealth fighter called the FC-31 or J-31 Euro Falcon. There is an expectation that the J-31 will become China's primary carrier-based fighter once it reaches full production, replacing the J-15. Aesthetically, the J-31 seems to borrow heavily from both the F-35 and F-22 22 programs suggesting that it may be lighter and more maneuverable than America's top-tier fighter. It is unclear whether the Chinese military will introduce the J-31 into service, though it's rumored it may be adapted for service on China's growing aircraft carrier fleet. Long-range to-air missiles in addition to sensors beyond visual range. BVR warfare depends on missiles that can engage enemies at greater distances at higher speeds and with greater resistance to decoys and jamming. In the last decade, China has begun fielding two highly capable BVR missiles. The first is the PL-12, which approached the US AIM-120C missile in performance and outranges the Russian R-77 BVR missile. However, China has also developed a PL-15 missile believed to match or exceed the range of even the latest US AIM-120D BVR missiles. The PL-15's dual pulse motor also allows a lethal second burst of speed as it approaches its target. Russia, meanwhile, has had difficulties fielding the R-771 missile in adequate numbers and don't currently have a direct Chinese or US equivalent, yet precision-guided weapons agree that it's more effective to get just one or two munitions to land precisely on target than cover a target area with lots of big bombs. Russia has developed various PGMs, but stocks are limited, so in practice the VKS has primarily relied on unguided bombs and rockets when bombing targets in Syria. Contributing to this problem have been the limited accuracy of Russia's GLONASS satellite network used to calculate bomb release and the inability of most Russian combat aircraft except Su-24, Su-25 and Su-34 that prompts most Russian pilots to more difficult and less accurate methods of targeting, such as hewing the entire plane around to paint a target, relying on the seekers of the wing-mounted munitions, or using TV-guided weapons manually guided by the weapons systems officer of a 2C jet like the Su-30 or Su-34. By contrast, targeting pod support or organic electro-optical targeting systems reportedly feature in later Chinese jets, including the J-10, J-16 and the J-20 stealth fighter. Furthermore, China is developing and exporting a diverse array of precision-guided missiles and bombs, many of which are available in scaled-down form for deployment on combat drones. Unmanned drones. Don't forget that unmanned drones are increasingly poised to supplant manned aircraft in the future. Some of these future robotic air warriors may be as exquisite and expensive as stealth fighters. Still, most will be far less costly and capable, and far easier to risk using in action due to their relative expendability. China has developed a broad spectrum of both reconnaissance and combat drones, UCAVs, ranging from relatively small and cheap CH-2 and Wing Loom UCAVs widely exported abroad to the jet-powered Cloud Shadow, the high-flying Divine Eagle hail surveillance drones, and the supersonic WZ-8 spy drone. Russia, meanwhile, neither operates nor exports any UCAVs, though it has announced it will begin fielding an unidentified UCAV in 2021. To be fair, the Russian ground forces does field various tactical reconnaissance drones like the Orlan-10 that have proven effective over Ukraine and Syria. While Russia's UCAV programs may eventually bear important fruit, it doesn't change the startling fact that China, Israel and Turkey operate and export multiple types of combat drones today that have no equivalent currently in Russian service. So what do you think about the rising China force? Leave us a comment below. Please give this video a like if you learned something new, and make sure you subscribe so you never miss another video from Front Cost. See you next time.